So our goal is to find the length of this line segment, right? So we want to find the arc length of the line y equals mx plus b from x1 to x2. So what I have highlighted here is the x components, x1 to x2, the y coordinates, y1 to y2, and here in pink this is what we're supposed to be trying to compute, is this length right here. Okay. Now we're going to use our formula. The formula that we're going to use is written on the right hand side. So let's see here. So here's our formula. Our formula is right here. Let's copy this and let's go ahead and get ready to do our calculations. So now we know that our f of x is equal to mx plus b. So let's go ahead and write that down. F of x is equal to mx plus b. Let me make this smaller. So f of x is equal to mx plus b. That's given to us in the problem. And then the bounds for x we can find by looking here. The bounds for x are going to be x1 and x2. So the length that we're looking for, which is the length of this, actually this is the length of a hypotenuse of a right triangle. And this length has x values between x1 and x2. So x1 is equal to a, and b is going to equal x2. So now going with our formula is going to give us, I'm using this formula right here for the arc length, is equal to the integral from x1 to x2 of the square root 1 plus, now I need the derivative, so if f of x is mx plus b, then f prime of x is just m. So I'll have m squared, because remember you take the derivative of f with respect to x and then you square it. Okay, and then dx. Now this integral is actually easy to compute because the inside here is a constant in terms of x. So the inside has nothing to do with x, so I can just bring it to the outside and I have the square root of 1 plus m squared times the integral from x1 to x2 dx. Okay, and that is just going to be equal to, so that we know how to compute, because the integral, this is the same as if I just had a 1 here. So I'll have equal to the square root of 1 plus m squared times x, and I evaluate it at x1 and x2. I'm using the fundamental theorem of calculus here. So I'm just going to get 1 plus m squared square root and then times x2 minus x1. So this is my official answer for the arc length. So what we're saying is that the length of this hypotenuse is the square root of 1 plus m squared times x1 minus x2 minus x1. Okay, now what I would like to do actually is to just double check this using trigonometry. So let's see if we can copy this. And now let's see if we get the same length using trigonometry. So from trigonometry, I can actually, first thing I need to do is I need to recognize like we said before, this is a right triangle. And so the length, or let's see here, so the hypotenuse is going to equal the square root of, one leg, the leg square, the square of the sum of the square of the legs. So be a squared plus b squared. A is this length. B is this leg. Okay. So now what is A? Now notice this A and B is different from the A and B for this formula right here. For this formula, A and B are the endpoints of the interval over which you're integrating. Okay, and here A and B represent the length of the legs of your right triangle. Okay, so what is A? A is going to be x2 minus x1 because that's the length of this leg. And what is B? B is going to be y2 minus y1. Now, what is y2? Because this point, so since x1 and y1, x1 comma y1 is a point on the line y equals mx plus b, that means we know what y1 is. So it must be that y1 is equal to m times x1 plus b. Similarly, y2 must be m times x2 plus b. Okay, so so we can actually compute y2 minus y1. We can simplify our b. So we're going to use this information here and plug it into this formula. So b is equal to y2 minus y1, but that's going to be mx2 plus b minus mx1 plus b, which is equal to mx2 plus b minus mx1 minus b, right? So the plus b and the minus b cancel out. We can factor out the m, and we'll have x2 minus x1. Okay? So we're going to put that back into our formula for the hypotenuse. So the hypotenuse is equal to the square root of a squared plus b squared, which is equal to the square root of, now what's our a? Our a is x2 minus x1. So we'll have x2 minus x1, quantity squared. And what is b? B is m times x2 minus x1. So we'll have m times x2 minus x1, all of that squared. Okay, so this is equal to the square root of x2 minus x1 squared plus m squared times x2 minus x1 squared. So we just distributed the two. And the last thing we can do is pull out a factor of x2 minus x1 squared. And we'll have 1 plus m squared. All of this underneath the square root. And so this is going to give us, this is going to simplify to exactly what we had over here. So notice up here we had the square root of 1 plus m squared times x2 minus x1. And that's exactly what you get when you simplify this down here at the bottom, right? Because this square root of the x2 minus x1 squared, we can pull that out and we'll be left with exactly what we got when we used our formula for L. So this is using the arc length formula. And this one is using the Pythagorean theorem. And you get the same result.